Hey guys, how you doing? Welcome back. Welcome back to another video. So today we are looking at a very interesting problem. It's called number of islands. It's lead code 200, and this is a medium level problem. But this problem has come up in various software interviews. For example, I personally have solved this problem at some of the top tech company interviews, and this problem has been asked at Google, Facebook, Microsoft, Amazon, Oracle, Bloomberg, and whatnot. Most of the FANG companies ask this question because this question focuses on some of the very basic but very important concepts of to understand your thinking. So without much delay, let us just dive into this problem. Cool. So fine, we'll be first going through the problem statement. So it says, given a 2D grid map of ones and zeros, where the ones are like land and zeros are water, we have to count the number of islands. So an island is surrounded by water and is formed by connecting adjacent lands, that is adjacent one, horizontally or vertically. Note that it's only horizontally and vertically, so no diagonal relation is there. So you may assume all the four edges of the grid are all surrounded by water. So outside this grid you may assume that it's water. So it's very pretty much straightforward to understand, like ones are the land and zero is the water. So you have to find how many islands, this basically how many connected ones, like clusters of ones are there. So okay, so I have taken up these two examples and I've put in a whiteboard so we can understand it better. So the first example, as you can see, these ones are connected and they are like horizontally or vertically connected here, and that's why they form a piece of land, piece of basically a cluster, and that's why he is only one island, and the solution for this is one. And for this one we have, like, this is one cluster, and you can see that this one and this one are diagonally connected, but we are only considering horizontal and vertical ones. So this is one piece of land, this is a separate one, and these two ones are horizontally connected. That's it, we have three islands here. So yeah, that's how we are that's the what is the problem. So uh, I think this is very much similar to a graph problem, because it's like finding the connected components kind of thing, basically finding a cluster. So if we have one node, we can find out if the nearest nodes are connected to this one, and for this one I have to find out if these two are connected. So basically for any node I have to find out like what are the four connected nodes to next to that, right? So it's directly has an inclination towards DFS or recursive kind of solution. I think also BFS can help in solving this problem, but I think for me DFS is coming for this problem much more directly, intuitively. So I would go with that. Yeah, so I would jump into the code and solving it right now. If anyone wants to solve it, give it a try. Do definitely give it a try, because that would improve your thinking, and you can pause the video and try that. So yeah, we'll be jumping into the solution. So yeah, first of all, what we need to understand is grid is the matrix given to us. So the grid has to be there. So just to check for corner cases, if the grid is there and the length of the grid definitely has to be greater than 0, only then we'd be doing everything. I would just put a variable for island count. Let's say islands as 0, and that will be the total solution. Basically, I'll be returning the number of islands here. So I'll just return islands, right? So yeah, so now I'll be iterating over it. So I have to, so basically I have to check every element, so every item. And if I go back to the whiteboard, so one second. So for this node here, I have to check all its like the neighbors, right? This neighbor and this neighbor. So basically if I have a node 1, I have to check all the four parts, all the basically all the four neighbors to that. So that's how we are going to perform a DFS. And let's code this out. So I have to iterate over all the nodes in the matrix and basically in the grid. So I'll just perform a nested loop, so it's definitely n square will be there. And yeah, so I just code in. So the length of the grid I'll take, and yeah, So that here goes row and this goes the column. And what's next is I have to check that. So I would only perform DFS if it is a land, right? Because for like lands where it's zero, I don't need to check if the neighboring ones are one or not, because I just need to check for connected components. If this is a one, right? If this is a one, I just need to check if this one is a one or not, and this one is this one is one or not. If this one if is what I'm looking for, I just need to check this one, this one, this one, and this one. So, and for each of them I will be checking their neighbors. But if it's a zero, I don't need to check its neighbor, right? Because we are only looking for pieces of land and they are like base conditions. For zero, it's like water. So it has to be land, so it has to be grid of ij. I think it's a string, yeah. So it has to be string 1. And if it's a string 1, so I just add on number of islands, and we need a DFS helper for this. So I'll write DFS uh, helper method, which will be writing. So that's the crux of the algorithm, and which will be performing the DFS. And I'll pass current index and the array itself. That's it. That's it. So I'll write the DFS function separately, and we can write it inside this class only to make it clean and much more readable. Modularity is a must when you're appearing for big interviews. So yes, sorry for the noise, guys. There's a construction happening. Yeah. So we get grid ij and self. Since it's Python, I'm coding in Python. Okay. So what's it we need to understand is if we need to handle the base cases. So let's say it's at the edge of the grid if I is equals to 0, or if j is equal less than 0, or let's say I is equals I is greater than, definitely greater than or equals length of the grid, or j is greater than equals length of the grid of that row, basically that total number of columns for that. So in that case, any of those cases I just need to return 0, because I cannot form an island there, right? So I just return a 0. Okay. And definitely if I somehow land up on a grid of 0, like if it's piece of water, I don't need to return 1. So that's not the case I'm looking for. So in other cases it would be what we are looking for. So I just mark, so all the visited nodes will have to mark with 0 because it was 1. So grid of ij was 1, or maybe we for all visited nodes will be marking it by 0, so that we don't visit it once again. So it's basically it doesn't end up in an infinite loop. And then we just perform the DFS method recursively on all its neighbors. So grid I j plus 1, right? I'll just copy this. So basically we had 4 neighbors. So I j minus 1, oops, and it should be I plus 1 j, and this is an I minus 1 j. So basically we have looked to all the surroundings, and since we have visited all, so I can return 1 for this. Alright, so that's it. If all of them would return 1, only then this one would return 1. Got it? So that's how we can I think design this. So I think that's it. So let us try running this code. Yeah. So yes, we are getting a good solution here. I would just try to submit this. Maybe try this test case once before submitting, because it's always good to like dry run it and then submit an interview. So yeah, I think let's check it. So this should give me 3. Oops, I think the test case needs to be passed clearly. Am I passing correctly? Yeah, looks like I'm passing correctly. I don't know why LeetCode is not taking this one. It's giving me a serialization error. Just give me a moment. and I think this would be good to go. Yeah. um, yeah, so this gives me 3. So okay, so we are good with the sample test cases. Let us just try submit this, and I think we'll okay, so we have to handle okay, cool. So we are returning islands. Okay, got it, got it. So for cases, we have done a little bit of bug here. Yeah, yeah. So I think that's good to go. So we'll just submit this. Yeah, as you can see, we have solved it. So that's it. Uh, I hope you guys like the video. If you guys like the video, do leave a thumbs up. It definitely helps me, motivates me to solve more problems and help to bring good problems to you. That's it for today. Have a great interview experience, guys. Good luck.